So I do have, okay, good, we have a little time. So I did want to point out there was this great tutorial on Kaggle about embeddings. However, it was recently removed. I don't really know why. It might just be like they decided it wasn't worth them putting in here. It is on Web Archive, so if I actually load this up, you can see what it used to look like. So kaggle.com/learn has a few tutorials and stuff like this going through. It takes a while because it's on Web Archive, but while that loads. However, the tutorials, at least as of right now, still exist from this data scientist, Colin Morris, who wrote the tutorials. They still exist on Kaggle and everything. It's just that they're not put on kaggle.com/learn. So you can actually still access this. So I went ahead and linked them into, here it goes. You can see this is what it used to look like, where they had the different, showing stuff like this of embeddings and stuff. And he will use the embeddings in these groups of lessons. He finds the embeddings with a neural network, but the idea is the same. It's like you have some kind of embeddings and stuff like this. So I thought this was a good thing to kind of check out. But I actually found the tutorials again here because I find they're really, really useful. I sing them with high praises and everything. So I kind of wanted to show you guys a couple of these things. So one, there's a few exercises here too that kind of build up the embeddings. But you can see here a little bit, he kind of goes through this data set with movie data set, where basically it's ratings from each user and stuff like this. So he actually goes in and creates this overall embeddings layer and creates this embedding. So here's a little bit of what's going on, where basically you take the user ID, the movie ID, and see if you can predict what the rating is. And the idea here is that you actually have in the middle of that, you can imagine this kind of a vector right here, or sorry, this part right here is kind of like the embedded layer where you can basically pull out this information. I'm going to see if he has another, it doesn't really show it on here, but basically the idea here is that it'll create this embedded layer, and that embedded layer now can actually use that to describe the users in movies, just like with SVD. Okay, but what's really cool is okay, we got the embeddings, cool, what do you do with it? Well, we can predict, how well this movie is going to fit with someone, but you can also do some really interesting things with embeddings. So one thing you can do, I'm so scared to things that kind of work because it's before. So I mentioned before, doing this dot product. So for example, this is the movie Twister. This is the user Stanley, and you can see in this case, this is the embedding. And what these numbers represent, who really knows kind of deal. But you can kind of equate it's oh, maybe this is something like action, comedy, romance, and so on. So there's some kind of latent properties of this movie. And this is how much, the user Stanley likes those latent properties. So if you do a dot product here, this basically is just telling you, okay, what is this predicted rating? Note that this, in this case, is actually scaled over. So you have to rescale it with 3.5 from what the actual thing is. So it ends up being predicting 2.43. So this is the way you can predict it. Cool, this is what we learned. But what's really nice, let's see if I can find it. Okay, so this is the next one, is you can actually do some interesting things like exploring these embeddings and saying, okay, because remember these embeddings are going to represent just basically, can you predict the rating based on the user? But this is actually going to give us information about how similar things are to each other as well. So whenever you hear similarity, you should think of distance. And I'm trying to find it right now. Okay, that's not what I want to show. I want to show this guy. So this is where basically you can imagine, I think he ends up getting, I want to say it's an 8-dimensional embedding. So 8 dimensions. And the problem is each of the movies exists little points in 8 dimensions. Oh, it's kind of hard to visualize this. So you can do dimensionality reduction with T-SNE, which either is TSNE or TSNE. I have no clue. I always just, in my head, I always think TSNE. That's all I think about it. But this is kind of what's going on here. But basically, you can project this down. And so this originally came down, I want to say it's 8 dimensions originally, but projected down into 2D. And what these points represent are basically all the movies. And what's cool about TSNE is that it will preserve the distances of these movies. So in 8-dimensional space, you can imagine they're going to be some are close together, some are far away, and it'll actually preserve where they kind of live on this 2-dimensional space. So even though it's not exactly, it's not a projection, because PCA will project it down, but you're going to lose some information. TSNE basically tries to preserve the relative distance to each other. Okay, so what's kind of cool, he does a little bit of exploration, saying, okay, here's all the movies, let's go ahead and look at things like finding all the Harry Potter movies. So all the movies that have the word Harry Potter in it. And it turns out this is little green dots. What do you expect? All the Harry Potter movies would be close together because they're very similar. So he actually zooms in on this. What's kind of cool is you can see here, here's all the Harry Potter movies, which are kind of similar to each other. But you see in this corner over here, it's all called Hunger Games. And that kind of makes sense. I mean, I think that makes sense to me. It's like, oh, you would think like Harry Potter and Hunger Games have kind of similar demographics for people who are drawn towards it, probably more like a teenager kind of movie kind of set. You know, it's focused on a teenager. It's also a series, so you can kind of see a little bit of similarities in here. But you can start looking at some other interesting things too. So the next thing he actually ends up doing, I think he ends up looking at like different, you know, genres and stuff. So he looks at, for example, documentaries, and he sees like most of the documentaries kind of stay over on this side over here. So you can kind of already see is that we didn't tell, like this distance is purely based on what users rated what movies and what their numbers were. So this kind of builds a little bit of a map of similarities. And you can kind of go a little bit further to say, okay, I think the next one he does, he actually shows a little bit of like different genres. So this one's a little tough to see by itself. Let's see if I can zoom in a little bit with this image. Okay, yeah, it works a little better. So you can kind of see here is that in orange and green and drama, these aren't the best like little icons, but they work well enough. So comedies in orange, dramas in green, and then romances in red. And you can kind of see drama tends to kind of float around here, though, you know, it kind of spreads over. Comedy is very concentrated off to the side right here. But what's really interesting, you can also see romance kind of goes from either on the comedy side, especially right here, but then it's also sprinkled in this drama. And you can kind of think it's like, well, okay, romance and comedy, probably like romantic comedy kind of deal. Like you can kind of see kind of that relationship. And this can help you build up a little bit of like a picture of these movies and stuff that are very similar to each other based on the distances. And these were just purely built, which I find amazing. It's purely built of just like ratings and users. We never asked, you know, what kind of user it is, or what kind of like, why did you rate it 3.5? Basically, you had enough information that you can build up this kind of like plot of like where things exist. So there's some really cool things you can do with that. Yeah, so anyway, I wanted to show you guys a little bit like why embeddings are useful beyond just like saying, oh, just predict the number, because it encodes some extra information. And essentially, embeddings are like embedding information into a vector that gives some extra information. One last thing I'll kind of point out with embeddings, which again, are pretty cool, is you can do things because they exist on a vector space. You can do things, let me see if I can find it real quick, like what movies are similar to each other. So for example, if you say, okay, like look for like the movie The Exorcist, and you can see what movies are similar. I'm trying to see what he did before. Okay, here's a good one. Like what are movies that are most similar to Toy Story? And you can see here in this case, like imagine if you're Netflix, like, oh, person like Toy Story. What movies are similar to Toy Story? Well, based on the embeddings, they're going to be nearby. So you can see here in this case, I think it's based on cosine similarity. But Toy Story 1 or 2, 3, which makes sense. Finding Nemo, that makes sense, like Pixar movies, Monsters, Inc., and Bugs Life, Incredibles, Ratatouille, Up, Wall-E, The Iron Giant. So note that most of these are just all Pixar movies. Those are the ones that are most closely related to it. But also there's a few other, like this one right here. Not necessarily Pixar, but this might be something that's relatively similar. It's more of a kid-focused movie and stuff like this. So this might be a movie that you say, hey, this is a little bit different from like maybe what you would say just Pixar movies. And note again that embedding has no clue these things have a relationship other than the fact that the ratings existed. There's some other kind of crazy kind of things you can do. For example, you can do like, this is really similar with word embeddings, but this is done with in movies that he tried out. It's like, imagine the movie Scream is equal to Psycho plus something. So the idea is like, there's something, you know, missing from, if you combine Psycho and another movie, what kind of, that movie would give you Scream. So the idea here is like, you know, what's the difference between Scream and Psycho? And you can see in that case, saying what the most similar movies are, combine them together, it's basically like Scream and Psycho, is you get Scream 3, Scream 2, it's like, okay, yeah, duh. But then you see like Piranha, Freddy vs. Jason, Final Destination, Booty Call, Charlie's Angel, Mortal Kombat, Deuce Bigelow, right? So you can start to see like what's going on here? And basically he kind of says, oh, these are comedies. Like the thing that's missing from Psycho versus Scream is there's a little comedy, you know, kind of comedic part to this movie. It's like, that's the thing that's kind of missing from here. So this is kind of interesting, like almost like analogies and stuff like this. So for example, you can do some really weird things like, you know, Brave is to Cars 2 as Pocahontas is to some other movie. And you can kind of figure out, like, okay, what these things are and stuff like this. It guys builds out a little bit of relationship of like what these things are just based on the embeddings. So anyway, that's a little aside. We'll definitely go more into this for natural language processing, because that's where it's most commonly used. Because based on this, I guess a little peek ahead for NLP. One thing we can do with words, at least in English, right, is you basically say what words are used nearby it. So the idea is that we can use distance similarity with words and figure out how they're related to each other, and using embeddings to basically encode some of that information. But anyway, a little aside about embeddings and why this works out really, really well. Yeah, so that kind of ends everything I want to kind of show today. Do you guys have any questions or any follow-up or anything like that? No? Okay, cool. So I can stop recording here.